All right, so for section 6.2, we're going to talk about laws of cosines. And with laws of cosines, it's a little bit more computational and maybe a little bit more, I don't want to say challenging, but a little bit more aggravating than the laws of sines and the setup. And so, I want to give you some insight. We use laws of cosine when given side measurements and side measurements. So only try to use laws of cosines when you have these situations. Otherwise, try to use laws of sines just for simplicity. All right, and so here are our values for a triangle. Just like when we had in laws of sines, we had a lowercase a. This was b capital C lowercase c. All right, and so our values for this is a squared is equal to b squared plus c squared minus 2bc cosine a. Yeah. And they all look similar. They're just a little different format because they all use the opposite or the sides that are not involved. So like b squared is a squared plus c squared minus 2ac cosine of the angle B. And then C squared is B squared plus, or excuse me, A squared plus B squared, doesn't matter on order, but A squared plus B squared minus 2AB cosine of the angle C. Yeah. And so this would tell us our side lengths if we needed to find a side length. However, if we need to find angle measurements, we can derive from this formula for our angle measurements. So the cosine of the angle A will be equal to b squared plus c squared minus a squared divided by 2bc. So as you can see, that's just been derived from that a squared equals b squared formula. The cosine of b will be equal to a squared plus c squared minus b squared all over 2ac. And then lastly, the cosine of the angle C will be equal to b squared plus, oops, need to erase it, there we go, will be equal to a squared plus b squared minus c squared all over 2ab. Okay. It's not harder than laws of sines, but it's a little bit more computational and just a little bit longer. So again, laws of sines, try to use it first, but we do have to use laws of cosines when given three sides or a side angle and a side where the angle falls between the sides. All right, so let's go over an example here of a side situation. So we have a triangle. Again, I'm just generically drawing a triangle where the A length is equal to 10, the B length is equal to 12, and C is equal to 16. And I'm going to find A and B. You would find C the same way, but once you know A and B, then you can just do the sum of the angles of the triangle, or whatever method, or you can use the method that we're talking about here. Okay. So the cosine of A, which I don't know what A is yet, is equal to, again, it's B squared, so 12 squared, plus C squared, so 16 squared, minus A squared, so 10 squared, all over 2 times 12 times 16, because it's 2 times B times C. Okay. So I plug this in the calculator. The only thing is I get cosine of A is equal to something. So I'm just going to go ahead and take the arc sine, or the inverse sine of both sides, and say that, or the arc cosine of this thing. Now you could find that number first and then plug it in to arc cosine. That's fine. I like to just go ahead and do it in one step, but that's just for me. Okay. So you plug that in the calculator. Be sure that your calculator is in degrees, and A comes out to be in 38.62 degrees. Okay. To find cosine of B, I would follow the same pattern. Cosine of B is A squared, so 10 squared, plus C squared, so 16 squared, minus B squared, so 12 squared, all over 2 times A, which is 10, times C, which is 16. Again, just take the arc cosine of both sides. And I'm just going to take the arc cosine of the whole thing. So when I plug it in the calculator, I just plug it in one line. Again, that's just for me. All right, plug it in the calculator, and you get 48.51 degrees. Okay. So that is how you answer when trying to find the angles. Okay. Again, it's just a little bit more computational extensive, but it's not bad. It's just a little bit more time consuming. Okay. So let's talk about one more situation here where we have a side angle and a side of a triangle. So I have the B side as 4.5. I have the A side as 100, as 9. And the C angle at 105 degrees. And my goal is to find side C, so the opposite of angle C. Okay. So referencing back to that list, now I'm finding side lengths, so I'm going to use one of these up here. And since I'm finding C, I'll say that C squared is equal to A squared plus B squared, that thing. Okay. So C squared is equal to A squared, so 9 squared, plus B squared, which is 4.5 squared, minus 2 times A, which is 9, times B, which is 4.5, times the cosine of angle C, which is 105. Okay. But again, this gives me a squared value. So I plug this in the calculator and I take the square root of it. So what I'm going to show you here, I'm just going to take the square root of the whole thing at once. I do this more for a rounding aspect than anything else. If you take the number, you round it, and then you take the square root of it or something else where there's more rounding involved, it could be enough to throw your answer off. So that's why I do this. All right, so just taking the square root of both sides, I get that C is equal to 11.05. Okay. And then if I wanted to find angles A and B, I would just follow the same process that we did with example 1. All right, so these are the only kinds of examples that you'll run into with this laws of cosines. It's a pretty short section. So if you have any questions, please feel free to email me. And as always, have a great rest of your day.